Okay, guys, so this is us reviewing for the quiz tomorrow. So I'm going to go through all of them. They're all pretty short, so I'm going to do it all in one video. All right, so the quiz review should be on the screen, and we're just going to go ahead and start. So 1 and 2 are when we're adding and subtracting complex numbers. So whenever it has addition or subtraction in the middle, you can only combine like terms. So the reals with the reals and the imaginaries with the imaginaries. So the real in this one is 4 and 3. So this will be 4 minus 3 because that's what we're doing here. And then that would give you 1. And we always write the real number first, and then you're going to do the imaginary. So you're going to do 6i minus negative 8i. Remember, whenever it's minus a negative, that really means plus a positive, and 6 and plus 8 is 14. And we make it 14i. Don't change that to I squared because we're adding and subtracting like terms. So we're not combining like multiplying. And that's the way we leave it, I plus 14i, or 1 plus 14i. All right, number 2 is the same thing. It's adding, so we're only combining like terms. So the real, so 5 plus 11, because it says plus in the middle, that's 16. And then we're going to do the imaginaries. So negative 2i, we're adding them together, and 8i, and that is a positive 6i. Right, so this is where, if you don't know, check it using your calculators. All right, and now we're moving on to multiplication. So whenever we have a complex times a complex, that's when we have to use the box or FOIL. It's not an option. You can't, I know a lot of you ask me, do we have to use the box? Well, you could FOIL, but it's still the same process. You have to multiply everything by everything. So 7 minus I goes on one side, 1 plus 3i goes on the other, and then you're multiplying. So it's 7, 21i, negative I, and then negative I times 3i is negative 3i squared. This is where we need to remember that I equals I squared equals negative 1, I to the third equals negative I, and I to the fourth equals a positive 1. So when we have this I squared here, this is really negative 3 times a negative 1, because I squared equals a negative 1, which makes that 3. So this box actually equals 3, and now it's like terms with this. So now I'm combining like terms, adding like terms, and I'm going to get 7 plus 3, which is 10. And then I'm going to combine these because these are still like terms as always. So it's going to be 21i minus I, which will give me a 20i. I remember it should always be the real and then the imaginary whenever we have a complex answer. All right, again, we're multiplying, so we need to do the box over here, and we're multiplying because it says squared, which means that we have 2 of these 5 plus 3 i's. So I'm putting them on both spots. 5 times 5 is 25, 5 times 3i is 15i, 5 times 3i is also 15i, and 3i times 3i is 9i squared. Same thing, I squared equals negative 1, so I'm going to replace that I squared with a negative 1, which makes this box actually equal negative 9. So when I combine 25 and minus 9, that gives me a 16. And then I'm going to combine the like terms, 59 gives me 30, so this is plus 30i. That's the final answer for this one. All right, the next two, 5 and 7, are different because it's an imaginary times a complex, which means we only really need to distribute. So we're just distributing the 3i to both numbers. And since we're multiplying, we can do 3i times 4. So 3i times 4 is 12i. 3i times negative 6i is negative 18i squared. We're never allowed to leave stuff as I squared because we know I squared equals negative 1. So this is really a negative 1, technically, times a negative 18. That makes that a positive 18. So it's 12i plus 18, but we don't leave it in this order. We always need to write the real part first and then the imaginary. So 18 goes first, and then it's plus 12i because this is a positive, not because this is a plus, because of positive 12i. So this would be the correct answer. Don't leave it as imaginary and then real. Right, when we do this one, we multiply again, we're just distributing 2i times 8i is 16i squared. 2i times negative 2 will give me a negative 4i. I squared equals negative 1. That's the one that you use the most often. And then 16 times negative 1 will give me a negative 16 minus 4i, and that is written in the right format, so I'm already done for this one. right, 7 and 8, they're just imaginary numbers getting either squared or cubed or to the 4th. So this 3i to the 4th means that I have 4 3i's getting multiplied together. 1, 2, 3, 4. So I'm going to pull all the 3's. So I multiply 3 times 3 times 3 times 3. And we can check this on our paper. 3 to the 4th power is 81. And then I'm going to pull all the i's. So I times I times I times I. That's I to the 4th. We look back over here, I to the 4th equals 1. So this is really 1. So this is really 81 times 1. That gives me 81. A lot of times people are adding them, but this is all multiplication. There's no addition anywhere. So this is just 81. So this imaginary number that got raised to the 4th power became a real number. All right, then this one is the same thing. It's just already kind of written out for you. Just notice that this one says that there's 2 of these. So it's really technically negative 2i, 4i, and then 2 3i's because it says 3i squared. So I'm going to do the same thing. Pull out all of these. Negative 2 times 4 times 3 times 3. Negative 2 times 4 is negative 8. Negative 8 times 9 is negative 72. And then I'm going to pull out all the i's. So I, and I. So same thing as the last one. Oops. Multiplication, there's 4 i's. So I to the 4th. I to the 4th equals 1. And then I'm multiplying negative 72 times 1. So I get a negative 72. All right, 9 and 10, we're using the powers of i's, and we learned this yesterday. So we already know the first couple powers of I. Oops, this is I squared. I to the 3rd equals negative I. And remember, you'll be given this set of information. So this will be on your quiz tomorrow. But then we realize that I to the 5th, it just keeps going around and around in a circle like this. So all of these also equal I, then the next one equals negative 1, the next one equals negative I, and the next one equals 1. And then it just keeps going. I to the 9th, I to the 10th, and you can keep going. So once we see that pattern, then we can just figure that out. So the main thing that's going to help you is that this is all the multiples of 4. So anything that's a multiple of 4 is going to equal 1. And then from that, we can kind of build up the rest. So I to the 13th is not a multiple of 4. So I need to find the closest multiple of 4, which would be 12, which we have right here. So if this is where 12 is, then we would keep counting on and 13 would be back up here. So I to the 13th would be I. So this is just I. And then I to the 44th. Now we wouldn't want to have to count. You could do it that way, but I to the 44th is a multiple of 4. So then right away we know it's 1. If it happened to be like I to the 46, let's say that. So then we know that 44 is the closest multiple of 4, and then we would need to count 2 on. So 45 would be here, and then 46 would be here, and so it would be negative 1. Just remember that these are not multiples of 3, and that's the biggest mistake I saw on people's cool downs, is that you were saying it's multiples of 3, and you can see they're not multiples of 3. 3, 7, and 11 are not multiples of 3. The only one that works is multiples of 4, and that's because we have 4 different numbers, so it's a cycle of 4. You have to do the multiples of 4. You cannot do the multiples of 3. All right, and then the last 4 problems are simplifying the radicals. So this is when we do the buddy system. So if you're using the prime numbers are 2, 3, 5, 7, 11, 13. I think those are the highest ones that you have to use for what we're doing. So you're dividing this by prime numbers. So like 2 would divide by this, you would get 50. Divide that by 2, you get 25. Divide that by 5, you get 5. You're just picking numbers. It doesn't matter what number you pick with. You're going to buddy them up. They have to be the exact same number. So the 2's get out and the 5's get out. So 2 and 5 both get out. So we multiply them and we put them on the outside of the jail. The negative always gets out, and it always slips out and becomes an I on the outside. So I'm going to put an I out here, and then there's nobody left in jail. There's nobody that doesn't have a buddy, so I don't need the jail anymore because the jail's empty. Which I could have thought, well, the square root of 100, we should have known is 10. So then I could just make it 10i. So remember to always check if it's on the sheet. All right, so negative 45 It ends in 5, so I know it divides by 5. 45 divided by 5 is 9. 9 is not prime, so I pick another number. 5 does not go into 9, so I can switch my number, and 3 goes into 9, and I get 3. Don't forget this last 3. A couple of you are doing that. You're forgetting the last prime number. So now I'm buddying them up, and they have to be the same number to buddy up. So the 3s get out of jail, so they go on the outside. And then the 5 doesn't have a buddy, so he has to stay in jail. And now this is what 45 would be, and since it's negative 45, this negative slips out of jail and becomes an I on the outside. So this would be our final answer. All right, for negative 20, it's even, so I'm going to start with 2. I get 10. That's also even, so I'm going to start with 2 and get 5. Now I'm at a prime number, so I stop. The 2s get out, so 2 goes on the outside. The 5 doesn't have a buddy, so he has to stay in jail. And then the negative always slips out and turns into an I on the outside, so it's 2i square root of 5. And then negative 72 is even, so I'm going to start with 2. I get 36. That's also even, so I'm going to get 18. That's also even, so I'm going to divide by 2 and get 9. 9 is not even, so I need to find a different number. There we go, 9. Divide by 3 and I get 3. Don't forget that last 3. So these two truths can buddy up, and it can only be groups of 2. And these 3s can buddy up. So 2 and 3 both get out. And I multiply them. So the 6 gets out. Now notice there's already a negative on the outside. So that negative is going to go there with the 6, because 2 times 3 is 6. So this is my 6 that gets out. This 2 does not have a buddy, so he has to stay in jail. So square root of 2 has to stay in jail. And now this negative always slips out and comes a negative on the outside, an I on the outside, sorry. And the negative is already out there, so that's why this answer is a negative 6i square root of 2. All right, that's it.